so tell me if it works. Yes, the link is in the Discord, of course. Quite sure I'm streaming to Twitch. Yeah. Do I need to like click on it myself or something? Okay. I don't like running a browser while doing this. Also, it was just like, it was like focusing or something. So I guess if I, yeah, like it auto adjusts a little sometimes. So I guess I have to just stay in the zone here. It's okay. You are in this microphone, right? The built-in mic should definitely be the, yeah. It's called built-in mic, but it's using the external one. So I didn't make this up. The Discord chat, but also the Twitch chat. Okay. Excellent. Oh, I hope I didn't have to prepare anything for this. Yeah, it'll be fine. I'm just gonna get a quick drink, and then it's gonna be time, and then be right back. Good evening. Is it working? There are people watching. Oh no. All right. We'll just wait a few minutes before we start with the actual thing that we're all here to do. Yeah, I got some fun facts, or at least I hope they're fun. I mean, last time we talked about the plague doctors and the evil and the death, which is topical for the times that we're living in. But you know, I just want to go with something else nerdy. So I have a question for you. It requires a bit of setup, and that will fill the minutes till we start. Nuclear fusion is a process of turning many atoms into fewer atoms, turning mass into energy, and it's the process that makes the sun work, right? That's how the sun works. And if we could only get it to work in power plants here on Earth, it would be pretty much free, pretty much limitless, clean, sustainable, safe energy forever, right? But getting that to work's been rather difficult. Turns out you have to make this hot plasma out of your fusion materials, which is deuterium and tritium mostly, which are isotopes of hydrogen. And you have to make that plasma so hot, like 10 times hotter than the core of the sun, right? To get enough energy in there so they could possibly fuse, the atoms could possibly fuse. Problem with that is, what are you going to contain that plasma in? If it's 10 times hotter than the core of the sun, there's no material that could possibly hold it. So what you have to do is you have to build these giant superconductive magnets with incredibly stupidly powerful magnetic fields that can hold this plasma in place, and then you make it hotter and hotter and hotter and hotter, and then you can get the fusion going. Hopefully. We're going to try this. We're building this monstrous device in Europe at the moment. It's called ITER. Don't ask me what it stands for. It's supposed to begin operating in like 5 years or 10 years, or I don't know. Look it up. Anyway, it's really cool. My question is this. This method of creating fusion, this containing this plasma with these giant magnets, that's called magnetic confinement fusion, right? There's another method of creating fusion, or that's under research at the moment, a competitor to magnetic confinement. Does anybody know what that is? Post your answers now. Hello. Look. Hi, cat. Do you want to do a coding dojo? Do you want to do a coding dojo? Yeah? All right, I have to unhook it from my shirt. Also, not get tangled up in these. It's cats versus cables, everyone. All right. No answer still. That's okay. The answer is, so I asked, there's magnetic confinement fusion, which is what we're trying with the ITER experiment, but there's also inertial confinement fusion. The idea behind that is you make these little pallets of some metal, and they have the deuterium and the fusion materials fused into them somehow. You have these fuel pallets, and then you shoot them suddenly with powerful lasers from all sides, and that would cause them to fuse, and then, you get the energy out that way. I think they're trying that somewhere in the US, but I don't know the details. There is also another way of doing fusion, but I've talked for 5 minutes. It's now 6 minutes past. I suppose we shall get started. I'm not actually getting any power to my laptop here, so let me just fiddle with the cable. Now the audio was glitching for a moment, but now it seems to be working. What a perfect time for a cable to break, right? All right. First of all, thank you very much for showing up on this perfectly serviceable Thursday evening. It is indeed Thursday. It is March the 25th at 6 o'clock in the Netherlands. And we're going to do another coding dojo, the second public virtual async, the second online CodingDojo. The last one was in December. We had the whole puzzle with the maze and don't use if statements and don't use return statements. Today we have another puzzle and we have another challenge. So without for much more noise, let's get to that. I can go to the main screen. Main screen turn on. There we go. Can you see the presentation? Excellent. In this presentation, first of all, the logistics of the virtual dojo, rebuilding your team, understanding the puzzle, and then accepting the challenge. Afterwards, there'll be some guidance on how to approach the puzzle for those that need it, and we'll have a look at how our teams did in the Maze Dojo, that one in December that I was talking about. So logistics of the virtual dojo. The stream is right here. That's this one. Hello, you're watching it right now. The Discord, join this if you want to collaborate on some coding after the presentation. So we'll be making the teams and I'll be available after to answer questions if need be. There are other people who helped organize the dojo, hopefully available as well. Previous streams, so the one about the maze, can be watched on this YouTube channel. This one will also be there at some point, I hope. And this file will be available as PDF, so you don't have to like type all that. You can just click on it. Building a team. We recommend a team size of 2 to 3 coders. Please reuse the team from the previous CodingDojo if you can get those people back together. That would be great. Otherwise, you can start a new team or join one, and we'll use the Discord text and voice channels to set all this up. So how do you do that? Just like last time, you can create a text channel and a voice channel with your team name. And then you can share bits of code there and links there, and then you can sit in the chat channel, the voice channel, and collaborate with people. It has screen sharing options, so that helps. And we'll not wait right now for people to get organized. Here's the Discord link. So these categories up there, they're left over from the previous dojo. You're free to ignore those. I just haven't taken the time to clean those up. You can create these text channels and the voice chat channels yourself. Pick a cool team name, get a few friends together, and we'll get to the action in just a few minutes. If you need help finding anyone to team up with, you can advertise in the general text channel. Also, I'll be around after the presentation. So let's talk about the puzzle that was there. Last time it was a maze. This time it's slightly less fancy, I'm afraid. The idea is this. Maybe you saw it in the ad for the dojo. I didn't make this, by the way. This is just a graphic I found somewhere. The puzzle is you have to find a key to unlock the door, unlock the gate. The key is a secret data structure that contains 1 string and 1 integer. You must issue challenges to the key to try and determine the correct values. So, the keys are, of course, randomly generated. The keys refresh every few minutes. And if you haven't figured out the correct values in that time, too bad, you'll get to try again on the next one. So, I'm going to develop an algorithm that does that. How do you do this? Well, there are HTTP, there's endpoints available where you can make calls that you can interact with to solve this puzzle. And I will explain those to you. First, you must, for your team, choose a client ID value and keep it secret. Because that's the thing that's going to identify your team against all others. And when you score points, they're credited to this ID. So keep it secret. Please reuse the client ID from the previous CodingDojo puzzle. If you have one, that would be nice. If you don't have it, don't remember, you can pick a new one. And then you can do an HTTP post with some JSON to /dashboard/decorate. You plug in your client ID right there, and then you can put in some team information. So you can pick a team name, maybe an icon, put in the names of the team members, and then there's a URL to where you want to store this, store your code somewhere where maybe other people can look at it. And there's an array for the coding challenges. We'll get to that one later. This is the same as it was for the previous challenge though. So if you did this for the previous challenge, you can do it again and overwrite the old information, or you can leave it be. That's up to you. This document will be available as PDF, so you don't have to memorize all this. I'm just going to explain to you what the calls do. So you can get the information of the current status of the key. It's useful to check this. Please do. You do an HTTP GET to /evaluate/status. And then you get a response that looks like this. You get a current key number. It's just a number. It increments every time that the key expires. If there's a -1 there, the puzzle's currently turned off, and you should wait until there's not a -1 there. There's an array of players who already joined. You can see their names. There's an array of players who solved the key. They are in the winners array. Your name will be there if you get it right. The key has an expiry moment. That's just a UTC, a universal time coordinate for when the key will be valid no more, and you will have to start the next one. Then there's the max number of entries and the max line length. You should keep those in memory. You're gonna need them. You should also do a get to /evaluate/characters, and that returns you a string of all the characters that you're allowed to use. So just to sort of limit the search space a little bit, there's a limited character set we're using for this puzzle. So how do you join the puzzle? Well, you do a post with some JSON to /evaluate/join. In that post, you put your client ID and you pick a nice player name. Don't pick this one. You get a response. You just get a player ID back to you. Just some GUID string that will be generated. It will be right there. Keep it in memory. You're going to need it. So when you join solving the current key. The current key has a number. It has an expiry date. When it expires or when you win, you'll have to rejoin for the next one, right? So the joining is only valid as long as the key that you joined on is there. So how do you issue a challenge to the key? Well, you post some JSON to /evaluate/run. In that JSON, you put this data. So you put your player ID, and then you put an array of entries. These entries are objects that contain a line, which is your guess for the secret string value, and a number, which is your guess for the secret integer value. And you can put as many entries in that array as the maximum number of entries that you got from the key status request. So if there's 1,000 there, you can put 1,000 elements in the list. If there's 100 there, you can only put 100. It can change during the playing of the challenge, so keep that in check. Additionally, the line, the string, may not be longer than the maximum line length, which you got from the same API call. So the string can be shorter, the correct string can be shorter, but it cannot be longer than the max line length. The line may contain only characters that you got in the call to /key/characters. If you put something else in, it's not going to work. So what will you get back then? Once you make this post, you will receive a response that will look like this. Basically, you will just have all your entries returned to you, but they will be outfitted with a score value. And the score value tells you how good that entry is, how close it is to being correct. If you find an entry with a score of 0, then you solve the key. Then you won. Then it's correct, right? So that's what we're going for here. After you solve the key, you will be sort of logged out automatically, and you cannot rejoin solving the same key because you already solved it, right? That wouldn't make any sense. You would just have it fixed immediately. So yeah, you just have to wait till it expires and then join the next one. I would give a special thanks to Gertjan, who is hosting the API at this address, dojomaze-api.maas.codes. You put that in front of all the other calls that I showed you earlier, and it should work. If not, I will yell at him. And here comes the challenge. So at this moment, you know what the problem is. Like, this is the coding problem that needs to be solved. Now we're going to look at how to make it even more difficult. So I challenge you to solve this puzzle in Nim. Nim? Is that even a language? Yeah, Nim is definitely a language, right? I didn't know about it until I started preparing for this one, but I turned out to actually quite like it as a language. I mean, it's a compiled language. It's not dynamic. It's not interpreted. So you actually compile it to an executable. That's nice. But at the same time, it still has that, a happy, hippie, hacky script kiddie feel that so many of us have gotten used to in the past few years, right? So it still feels very accessible. So to make it even more accessible, because I know some people are just very not eager to step out of their familiar programming paradigms, I made a starter for you. In the starter, you get a hello world for Nim, but also you get the type definitions and the functions to call the API of the puzzle ready-made for you. You just have to call them. You don't have to waste time setting up clients or parsing JSON. It's all there and it's good to go. Additionally, there's scripting there for installing and running Nim, at least on Mac. And on Windows, it's like a good example on how to do it. So I couldn't make it any easier for you to take up this challenge in this way than I did. Still, I want to say if you really, really don't want to, and you just want to do the puzzle in your own language, I can, of course, not stop you because I'm not a manager and I'm not in charge of anything or anyone here. So, but this is the challenge. Go ahead, see if you can do it. And if you do the post to the dashboard where you declare your team and you have to put in the coding challenges, put Nim in the challenge so that we know that you are building the client that solves the keys using this language and framework. Oh yeah, this is kind of good to know. This is the link where you can get this starter. Just clone it from there and then good to go. Now, on this broadcast, we will continue with genetic algorithms for absolute beginners like myself. And after that, we will have the winners of the Maze Dojo. We'll review some statistics gathered by the Maze engine when our teams were valiantly trying to solve it. That's that. Are there any questions so far from the audience? I will click on this. Hello. the PDF will be available on the Discord server. I actually still have to print them. Like I have these PowerPoints, but I didn't print them to PDF yet. So as soon as the broadcast is done, I will do that and I'll post them on Discord. And then you will have them. I have some tea. All right. Then we shall continue with genetic algorithms for absolute beginners, which I have right here. It's only a couple slides. So is the other thing. It's just a few slides. Then we'll get to the chatting and then we'll get to the coding, which is much more fun, I'm sure. So, genetic algorithms for absolute beginner dummy noobs like myself. Genetic algorithms are kind of machine learning light. They're kind of like a poor man's solution to clever algorithms. It's like throwing data at a problem to see what sticks, right? When you don't know what to do, you can use a genetic algorithm. And the puzzle is made exactly for solving with a genetic algorithm. So this puzzle, you put in your challenge, like a line and a number, and out comes a score. And you can think of the line and number, the entry, as a sort of an individual in a population, and that is its genetic makeup. Its genetic makeup is that line and that number, and the score it gets is its fitness. It's like how well does it fit the situation. So it's an individual and it has a fitness, and then we can use evolution to evolve our individuals. So first, some context, right? Let's say that the string of the line is maximum 30 characters long, right? Let's say all the possible different characters are all the uppercase letters, all the lowercase letters, so that's 26 plus 26, plus all the digits, that's 10. Let's add some special characters, let's say 6. Then it's 68 possible characters for every character in a 30 length string. Then there's a number. So that's 0 and then all non-negative integer values in int32. That is this number. I don't know how to pronounce that. That is a big number. So you multiply all those together and you realize that the chance that you'll randomly generate the correct line and number is this, calculated out, is roughly 1 over 9.7 E54. I don't know how small that is, but that is small. I bet you're more likely to win the lottery that you didn't even play in. So it's like someone in your family buys the winning lottery ticket, then they die and you inherit it, and then the lottery ticket wins, and the odds of that happening like twice in a row or something, I don't know, it's very unlikely. You could randomly generate lines and numbers and throw it at this puzzle all day, every day, and you wouldn't guess it. That's how big this search space is. And like I said, I made it smaller on purpose by constraining the number of characters you can use. The standard character set is a lot larger than 68, right? So how do you approach this? Well, like I said, you generate a lot of individuals, a lot of random strings and numbers. And then for each of those individuals, you get a score using the API. Use the API, get a score for all your individuals. Then what you can do is you can sort them by score. The highest scores on top, the lowest scores down below, and then you delete the lowest scoring half, maybe 50% or 25% or 75%. I don't know. You figure that one out. But this is the equivalent of saying all the individuals in my population below this fitness don't survive to the next generation. So this is where the evolutionary pressure is exerted on your population. For each deleted entry, then, we should populate a new one. You can do this by generating a completely new random entry, but you can also generate a new entry by copying some of the high-scoring entries and then randomly tweaking the values a little bit. You can make new entries that way, or you can generate new entries by sort of randomly combining some values from high-scoring entries. Right? It's like simulating the process of these individuals mixing their DNA to produce new individuals, right? So you can do all three of these, obviously, but to what ratio will you do them? And in which situation do you do more of one or the other? This is stuff for you to find out while doing the challenge, but the result is you end up with a new, complete set of entries. For these new entries, you can then get a new score and you can profit and repeat. And eventually, you will find the solution to the puzzle that way. And this is genetic algorithms for dummies. Any questions? Well, we have some time, and these files will also be available. This is just my take on genetic algorithms. Like I said, I'm an absolute dummy in this regard. I'm not a data scientist at all, and I have yet to find a real world, professional project situation where I've had to deploy a genetic algorithm to solve something. I'm just eager to do it, though. I'm just eager to actually use a genetic algorithm in a production system. It's space searching, right? So there's an incredibly huge space of all possible entries that could be fit in here, and you don't have time to try all of them. So this is a way to search that space more efficiently. The thing you need to have is an evaluation function, like something that can give a score or a fitness to your attempt. As soon as you have that, you could, in theory, deploy a genetic algorithm. All right. Then we shall briefly look at the results of the Maze Dojo. Actually, what I wanted to do was some code review on exactly what people did with the challenges that we posed for the Maze Dojo, which was don't use if statements, no ifs, no buts, and don't use return statements. It's tell, don't ask, right? Love these challenges. Love them. Do them every day. Anyway, we'll just look at some statistics, and we could review some code, but unfortunately there's not a whole lot of code to review. So we'll just see who won, because that's really what we all want to know, right? We want to know who won the Maze Dojo. Well, these are the teams who were playing in the maze back in December. I took the score out of the database a little later, so people who played later than the actual dojo date, they also got in. These are not mistakes, by the way. These are just teams that didn't fill in a team name. So I'm going to pick names for them. This is now Team Squares, and the other one is Team Circles. So then we have Team Amazing, Team Ginger, Team Squares, Real Python, Recursive, and Team Circles. Let's see how they did. So these are the team members who were filled in at the API level. So hopefully that helps you remember where you were. Right? And so here are the winners. The most exceptional, statistically exceptional events that occurred. Who completed the most mazes? That would be Team Amazing, who actually completed 35 mazes in total. That's quite a few. I believe the next one up was like 12 or 15 or something. So who completed the largest maze? Well, it stands to reason that if you completed the most mazes, then the same team actually completed the largest maze as well. The largest maze was 550 squares, and they managed to solve that one. Who completed a maze the fastest? Actually, we have a tie. Team Squares and Team Amazing both completed a maze in only 27 steps. It's like they ran straight for the exit with their algorithm. It's great. So who was the slowest at completing the maze? Who completed the maze the slowest but still did complete it? Because remember, if you didn't complete the maze, you don't end up on the scoreboard. So the slowest was Real Python, who completed a maze in 775 steps. Now that's impressive, and I'll tell you why. You can only take a step once every few seconds in the maze, and it takes a couple of seconds before you're allowed to take a new step. So this number of steps translates to a number of seconds. Also, the mazes have a limited lifespan. They get recycled by the game engine every couple minutes. Right? So this means that this algorithm, it joined like at the earliest moment and took a maximum amount of time to still complete the maze. And they did complete it in 775 steps. So that's interesting for that reason alone. The most dangerous team was Team Ginger, who managed to stun 31 other players in a single successful maze run. That's what I said, right? Yeah. So that's impressive. I believe this team actually implemented the shooting part of their algorithm before they implemented the part that was supposed to recognize the exit. So at some point they were running their algorithm and it found the exit, and instead of running towards the exit, it started shooting at it. So it needed some tweaks still at that point. So not strange that they were the most trigger happy team out there. The least dangerous or the easiest target was Real Python, who managed to get hit 7 times in a single successful maze run. So he got shot 7 times and still managed to complete a maze. That's determinism. Or determination, I should say, but it's also determinism. I mean, unless there was a random generator in there. So we could review some code. Which teams managed to provide a repository URL that contained reviewable code? Well, it was only Team Amazing, and their code is right there. So we could have a look at it, or you can have a look at it if you want. I looked at it. I thought it was quite a nice bit of code. It's a single file that did all the work. But for now, I think I want to stop talking. I want to leave it here, and we'll go to Discord. So, hello, I'm back. Hi. Are there any questions regarding anything that was talked about the past, 40 minutes? I suppose figuring out how the scoring is applied is part of the puzzle. Yeah, so the scoring is done by the engine. It compares your challenge to the correct values and then gives it a score. How it does that, I spent a lot of time tweaking and fine-tuning so that the puzzle's solvable, but you don't really need to know exactly how it does it. All you need to know is for each individual, for each entry that you post, what's the score I'm going to get? How then can I proceed towards the correct answer? If there are no more questions, I shall thank you very much for tuning in, for joining, and I will see you on Discord. We can have a chat and a drink and some coding. Boy, I need a drink after this. Thanks very much.